Hi, and welcome back to another AnyRPG Development Livestream. In this video series, you can watch the live development of the AnyRPG Engine, a free and open source role-playing game engine designed in Unity and written in C#. If you don't already have a copy of AnyRPG, you can pick one up from anyrpg.org/downloads in both Unity package and source code format. You can also find A Lost Soul, the free playable game that I work on in these episodes, available for download at the same page. So in this episode, we will be continuing our work on the custom character stat system. We added a new character stat class to allow character stats to be definable by the character, and we added secondary stats that we can define as a relationship to the primary stats. We can control all this through the character class object, and we can also define like power resources, and health is now a power resource as well. It's no longer hard-coded into the engine. So in this episode, we are going to be continuing that work and hopefully getting it finished up. We've done basically most of the main code, but now that I'm looking at this, I'm thinking that essentially we have stats up here. And we already defined stats, and then we're basically like redefining them down here with these conversions. So it kind of makes more sense that these should be up here now. Similarly, if you look at the channeler class, he's got a stat conversion for mana to intellect, and this is a resource stat conversion, not a secondary stat conversion like these ones are. But still, it makes sense that now that we have these stat objects that are definable, which we didn't before, we can move this up there as well, and then that way, whether you're looking at a character class or whether you're looking at the system configuration manager, when you define your stats, it's going to be exactly the same. There's just a single object to include there, so that'll make it a lot easier. So basically that's what we're going to do today, and then we also have to deal with death conditions. Sorry, I'm just getting a little bit confused here. For some reason, I think this was like 0 before, and suddenly it's 4. But I think what happened is it refreshed these values from the base game manager because I had added them there. Okay, so what we're going to do is, we're going to do those minor changes, and then we're going to work on combat, because right now in combat, I haven't changed it yet. Like, you can attack someone, but they don't have like a fixed health thing, so we need to actually make health like a resource that you attack when you attack someone. And we also have to set death conditions. So when, for example, like what if you give someone a resource that isn't health, like you're fighting a boss and the boss basically has like armor and a shield, and when the shield's down, the boss is considered dead. So we have to define like what power resources are actually contributing to the character's life. So let's get started on that. The first thing I want to do is move everything into this primary stats object here. So let's see, looking at the Ranger class right here. No, I did it on the Warrior class basically. So I defined these relationships, strength to damage. Also, another thing we're going to need to do is this power to spell damage and power to physical damage. We'll have to replace that basically for damage and melee damage, and we'll have two separate ones. So what that means is that a warrior, for example, could have his strength give him a different amount of spell damage compared to the physical damage. So that we don't have to have warriors equipping intellect gear, but we don't want to give them like an underpowered amount of spell power or an overpowered amount, because they also get weapon damage. So let's go ahead and do that. So what we're going to do is we're just going to go into this enum right here, which is primary stat type, secondary stat type. And we have damage, melee damage, and we'll have spell damage as well. And then we'll let that show up here. And then what we want to do is we want to take this node, whatever this type of node is right here, which is the primary to secondary conversion object, and we want to remove the stat name from it and then move it up underneath the actual stat scaling object. So let's go ahead and do that next. So we need to look for the primary to secondary conversion on the character class. So we have the just a second. So this is under Power Enhancer Stats. Okay, so we need to look under the Power Enhancer Stats object for the primary to secondary conversion. So this is the Power Enhancer node, and we're going to take this primary to secondary conversion, and we're just going to grab it and move it up underneath the stats and scaling primary stats object on character class. So we'll go in a character class, we will look at the stat scaling node, which is basically our primary stat object. We will go to the definition of that, and we'll add this. Okay, good. And then why don't we add a tooltip on budget per level? What is a budget per level? You know exactly this. So a budget per level is the amount of this stat that a character will receive for every level. And then the stat name, I mean, it's just the stat name, that's kind of obvious, but the stat, yeah, sure, why not? All right, so then we'll want to expose this primary to secondary conversion, so let's just encapsulate that. And then in this primary to secondary stat node, actually let's just let that compile and just take a look at what that looks like. I always like to see this stuff in the inspector. It makes a lot more sense once you see it in there, and it's easier to fine tune it. Okay, so here we go. So now strength for the warrior now has a primary to secondary conversion. So we need, let's see, 2 primary to secondary conversions here. And actually, you know what? I'm going to do 3. I'm going to take advantage of this whole like separate spell power versus physical power and just play around with it because I want to make sure it works. So here, we no longer need the stat name because the stat name is right there and that information is now redundant. So we can remove the stat name. I'm just going to set these first so I don't lose that information. So basically I want melee damage, and I think these are also redundant, this direct versus stat. So the ratios for both of these are 0.5. Okay, so let's go in and clean that up. Let's let's do spell damage at a stat name, or I mean at a conversion ratio of 0.5. It's not rated. Melee damage at a conversion ratio of 0.5, also not rated. And critical strike needs to go under agility. So that means that our warrior needs to also have agility defined. He's not going to get any additional budget per level of agility, but we do need to define it so that we can define his stat conversions. He only has one stat conversion for agility, and it will translate into critical strike, and that is rated at 0.5. Okay, that looks good. So now let's go, now that we've transferred that information so that we won't lose it, let's go remove stat name and this field right here, stat rating ratio, and then change this just to conversion ratio, and then rated conversion or not. So we're going to call this conversion ratio. I'm actually going to lose the information in there, but they were all 0.5, so that's fine. We'll remove the rating ratio, set this to conversion ratio, set this to conversion ratio. Right, so we need to basically put this description on here, and maybe this is going to be a really long tooltip, but that's fine. Okay, that should be good. Also, right, we don't need the stat name either. Okay, we have some issues here. What issues do we have? Right. I didn't do like an actual rename on that object. That's fine. We need to fix this anyway. So basically, these are all just grabbing the conversion ratio. Okay, and here, we need to actually loop through a different object now, because my power enhancer stats is no longer needed, basically. So these were the power enhancer stats where those conversions were coming from. So let's just go and take a look and make sure see if we have that information for the other classes too. So we'll go to channeler, character class, and we'll just check. Yeah, so we should add those. So basically the channeler gets intellect converted to critical strike at a ratio of 0. No, I want intellect converted to spell damage at a ratio of 1. And then I want intellect converted to critical strike at a ratio of 0.5. For the fighter character class, he's got 2 of them. We will be converting agility to attack power at 0.5. And rated agility to crit at 0.5. And direct conversion ratio. You know what I want to do? I'm going to formally serialized as this. That's interesting. It doesn't want to do it. That's really strange. So we'll have this formally serialized as direct conversion ratio. And I really don't know why. Oh, do we need to add using Unity Engine.serialization? Ah, that's better. Okay. Okay, good. So we've got these two, and then let's go back to that character class. So we want to go back to the fighter character class here. And actually on the channeler, I just want to make sure that I rated the conversion for crit. Yeah. All right, and good. So for the ranger then, same thing, basically agility. So we've got 2 stat conversions on agility for the ranger. We've got just straight up damage, and we have critical strike, and this is rated at 0.5, and this is direct at 0.5. And then we've done the same thing with the warrior. We've moved up his conversions. And actually, let's see here. We did the strength conversions. He actually doesn't need 3 there. He only needs 2 because the crit conversion is down here. Okay, that looks pretty good. And then Basically, these aren't needed anymore either because we have strength per level at 5. Just go into the ranger, make sure agility per level 5. Going up to the fighter, make sure agility per level 5. With the warrior, agility per level 0. And with the channeler, intellect per level 5. Perfect. So now we can get rid of the entire power enhancer stats object, as well as all of these hard-coded per levels on the character class. So none of that is needed anymore. And that means we can also get rid of all this. Okay, so now we have some issues here. And let's see, so in level equations here, we're saying get primary stat for level, but we're passing in the stat name. Okay, right, because we're getting any primary stat. I'm thinking like primary, like stamina or something like that. Okay, so what we're doing here is we need to grab the value. So here, we no longer have my stamina per level. We got to do something about the class name. So we're already doing the stat scaling node here. So basically we just need to grab that. So we grab the stat scaling node dot, and what are we grabbing here? Primary stat amount. Okay, we were previously grabbing my stamina per level. So now this is the budget per level. This is an int. This is a float. We're going to cast that to an int. Okay, and then right here, we're doing the system configuration manager version of the same thing. So we will grab its scaling node dot budget per level. Okay, that's good. And then here we've moved this object, the power enhancer node, up into the character class's primary stats. So let's see what we need to do then. We need to instead look through, let's see, I guess the first question is, we're still using Power Enhancer node? I don't even think we're using Power Enhancer node. We stopped using it, didn't we? Because this was the Power Enhancer node, and we've moved all those up under the stat budget, just using the primary to secondary conversion. Meaning that, right, we removed this completely. So let's just find all references to Power Enhancer. Oh, you know what? This is actually the class here. We kind of need this class to remain here because I think the file is named after it. Okay, so for now, basically if we go into the character class, we look at our primary stats, which is a stat scaling node. And the stat scaling node has a list of primary to secondary stat node. It doesn't have Power Enhancer stats, so we don't need Power Enhancer stats. So what we want to do is look through in the my character class dot primary stats, which will give us a list of stat scaling node. And I'm just going to rename that to stat scaling node. All right, and then for each primary to secondary stat node, which is right because the primary to secondary stat nodes. Okay, perfect. So basically that's all we have to do. We just have to fix that. And then here we're going to do the same thing for the crit chance. We did not going through Power Enhancer nodes. We're now going through stat scaling nodes in primary stats. And I'm just going to rename that stat scaling node. It'll work whatever it's called, but it's just a lot easier to see that. Similarly, when we get the spell power, okay. Here we get spell power and we get physical power. We need to change the logic behind this a little bit because we had this power to spell damage, which is no longer in use. The way that we're doing it now is spell damage is actually its own thing. So essentially what we want to do is for spell damage, we want to pretty much take like the damage plus the spell damage stat and add them together. And for the physical damage, we want to take the damage plus the physical damage stat, and we want to go and add those together. So first, we want to actually just change this to say conversion ratio. And this one should be the same thing, conversion ratio. And then let's see, we're looking through a stat scaling node in primary stats, and that to stat scaling node. And let's see. What we want to do is, I think we don't care about this, because what we're going to do is basically just go through and check if it is equal to damage or equal to spell damage. So here we're going to copy that and say or equal to spell damage, and that'll basically end up adding both of those together. So then we can remove this if statement right here, because this gets done now no matter what, and we can hold down Control K, Control F to fix the formatting. Okay, now here, because we're going through a stat scaling node, to get the name of the stat, we now grab it from the stat scaling node dot stat name. And that should work. So let's save that. We've got some more red text up here. So similarly, we're going through the stat scaling node dot stat name there. Have a little more red up here. Similarly, we're going through the stat scaling node dot stat name there. We've got a little more red down here. Okay, so for physical power, we need to do the same thing. We are going to remove this if statement. Then Control K, Control F to fix formatting. We will be going through stat scaling nodes in the primary stats. We will be calling this stat scaling node, just for clarity. And here we will be adding a statement saying that it's damage or physical damage. Then here we can just call the new variable conversion ratio. And out here, physical damage, what did I call that? Melee damage? Yeah, I think I melee damage. Okay. Let's just go and make sure. Go to the definition. Damage, melee damage, spell damage, yeah. It's not really melee damage, it's more physical damage actually. Because archers can use arrows and that damage is still considered physical. So we'll save that and call this physical damage. Then the stat name is coming from the stat scaling node. And same thing there. Okay, good. That fixes up everything in level equations that was depending on those things being in another place. Okay, that's good. So now we can see basically that whole section is gone and everything is showing up here. Perfect. We don't need the name anymore. And we lost the conversion ratios, even though we put in formerly serialized as. Okay, well, fine. Let's go back and look at the warrior character class. Yeah, we lost them for everyone. All right, we'll go remove the formerly serialized as from the... Oh, you know what? No, look at that ratio, direct conversion ratio. I've had an N in there. Let's let that compile and see if I get my values back. No. I think because I already looked at them. Okay. Whatever, fine. We're just gonna, maybe, did I spell anything else wrong? No. Okay. It's fine. We'll save that. Get rid of the formerly serialized as, and we'll just go reset all these values. So, spell damage was 1, critical strike was rated at 0.5. For the fighter, there was 0.5 for damage, because they get a weapon, 0.5 for crit as the rating. For the ranger, same thing, 0.5 points into damage, and then 0.5 rating into critical strike. And then for the warrior, what were we going to do with him again? The warrior, we were going to give him more spell damage because he gets, like, from his weapon, some damage component for the physical damage. So let's do a conversion ratio of 1 for spell damage. This guy's going to be insanely OP here. And then similarly, agility, 0.5 critical strike rating. Okay, good. So then we need to do the resources now. So for our channeler right here, we have our stat to resource nodes, and we're grabbing this value right here. So what we need to do instead is swap this node. So instead of saying stat name, it says power resource name. And then we'll take this stat conversion list here and pull it up and this is stat to resource conversion, and we'll pull it up here basically into the stat. So let's go look at that. Basically we need to go look at this object right here, find this thing, and then move it up there. So we want to look at our stat to resource nodes in our character class. So right there we have a stat to resource node. We're going to go to the definition of that. We're going to find this list right here. We're going to move this up into our stat scaling node. So we get our primary to secondary conversion, and then our, and we'll call this something a little bit different. This is our primary to resource conversion. And this is going to be convert primary stats to resources. Okay, that looks good. And then we'll want to expose that. So quick actions and refactoring, encapsulate field. and we can save that. And then we want to go down to the character stat to resource node there. And here, instead of the stat name, we want the resource name. And this will be the name of the resource that will receive, what did I see? Receive amounts, basically, that will receive points from the stat, I guess. Okay, we'll let that compile. And it looks like we've got 2 issues right here. Okay, so this is basically the exact same thing. Instead of looking through the character class's stat to resource nodes, we're going to be looking through the primary scaling nodes. So right here, we will look through the, just a second, I need to change that, the my character class dot primary stats, which will give us a stat scaling node. And we will rename this to stat scaling node and apply. And then here, we didn't call this stat conversion. We called it primary to resource conversion. And then here, the stat name actually comes from stat scaling node. And then the resource, let's see what we're sending in here. We're sending in a power resource. Okay, so we're just putting in a resource name right now, which is going to be in the character stat to resource node. So we need to actually turn that resource name into a reference to an actual resource. So let's see, we can do that at runtime. Yeah, we might as well. You know what, actually, see, we can do it at runtime or we can do it at startup, basically. Like, I have this whole concept of set up scriptable objects, which goes through and gets references and turns text things like into cached references. If we go to the, for example, like the character class right here, you can see we actually run this right here already, set up scriptable objects, which is getting references to power resources. What we'd want to do is we'd want to go through and get references on all of our stat scaling nodes. Okay, so I'm gonna, I think, move this code, because basically this does exactly like when I pulled out that object, but I didn't bring the setup scriptable objects with it, so we were basically already doing that. So we want to go put setup scriptable objects on the node that holds the character stat to resource node. which is the stat scaling node. And actually, let's see, no, we want to actually put it on the character stat to resource node. And then, let's see, we've got the resource name here. So then we need an actual reference to it. So private power resource power resource. And we need to expose that then. And then we will actually need to call this. So where we're referencing the character stat to resource node, actually, let's just call that, or copy the whole thing. Our character stat to resource nodes on the stat scaling node will need to be initialized. So we'll need to have set up scriptable objects here. And what we'll just do is a quick for each loop. So for each character stat to resource node in primary to resource conversion, character stat to resource node dot setup scriptable objects. Okay, and then we'll basically want to do the exact same thing on whatever contains a stat scaling node. So we'll find all references to the stat scaling node, and that is contained in the system configuration manager. So actually, let's see, this is kind of interesting. The system configuration manager may have actually been loaded before we loaded like anything else at all. The game manager, for example. This is easy enough to do inside a character class because character class already has a set up scriptable objects. Let's see if I can find it here. Character class is not using, there it is, yeah, set up scriptable objects. Okay, so for the character class set up scriptable objects, we have our stat scaling node called primary stats. Oh, in fact, you can see we were even doing it right there already with the previous nodes. So for each stat scaling node, rename that to stat scaling node in primary stats. Go ahead and set those up, and Control K, Control F, and we no longer have stat to resource nodes at the root level anymore, so we can remove the setup from those. Let's save all that. And now I need to go back and look at the system configuration manager. So here we finally potentially have a reference to that power resource. Let's go check. We've got another issue right here. For the get resource maximum, this is coming out of the character class's stat to resource nodes, which no longer exist because we moved that up into the stat scaling nodes. So that means that we can remove this heading and that variable. We no longer need those. And now let's just go down here and see. We're going to be looking through the stat scaling node. Rename this to stat scaling node, and we have stat to resource nodes. This will be primary stats, and if here we have to let's see. I may not have exposed it yet. Let's go to stat scaling node. So the stat scaling node has a list of primary to secondary and primary to resource. So we need to, I think, do a for each loop then. So we need to look through the primary stats dot oh, sorry. What is this? Oh, no wonder. No, okay, just a second. Primary stats is a list of stat scaling nodes, correct. So, oh, right. We want, sorry, stat scaling node dot, yeah, that's better. We want the primary to resource conversions, and then we can move that block of code inside the for each loop, and if, and in this case the primary resource conversion is a character stat to resource node, so we will oh, you know what? We're already basically doing that. We're looking through the character stat to resource nodes in the stat scaling dot primary to resource conversion inside there. So what we actually need to do is basically just like move this if statement inside the loop. So let's get rid of that, take this for each loop, put it out there, move this if statement inside there, and then put the return value inside the if statement. And then finally, we can check if the character stat to resource nodes power resource equals the power resource. Excellent. And then Here, we want the stat name, and the stat name is coming from the stat scaling node. Okay, much better. We'll let that compile, and we've got still that one issue right here. Right, so I still have to go back to the game manager and just make sure that we're actually loading all of our objects before we load the system configuration manager. Otherwise it won't be able to get a reference to the power resource. So that's all handled by this object right here, the system game manager, and it controls the startup order for everything. So we load our resources. Basically, verify system abilities is the closest thing that I think it looks like our system configuration manager has to a startup method. Let's just go to the definition of that. It creates event subscriptions in the start method. Okay, so verify system abilities is basically like where this is the closest thing to the setup scriptable objects. You know what? Hey, look at this. This is setup scriptable objects. That's exactly what this is. Because I'm already grabbing resources basically from the system managers. So we're actually going to rename this to setup scriptable objects. And then we're going to go down into the character class and we're going to find where we're doing our setup scriptable objects call right there in our stat scaling nodes, and then we can go back to our system configuration manager and we can do the same thing. Do we even call it primary stats? We did. Okay, perfect. That should compile now. Nope, still not. Okay. Right, so we can count on the auto-scaling node actually having a reference to the power resource. So now we just need to go to the stat scaling node, we need to go to the definition of that. No, we can count on the stat scaling node's character stat to resource node, which is the character stat to resource nodes, power resource. Yes, good, that'll work. Let that whole thing compile. Okay, much better. So now we can define all of these things properly inside of the game manager, as well as at the individual class level. So we'll go into this folder here and let's check this. So what I want to do for testing this, in general, what I'm going to do is I'm going to give health to everybody at the game manager level. So if we go into the Lost Soul game manager, you can see we're giving stamina to everyone right now. And what I will do here basically is just give everyone health at a resource per point of 10. So you get 10 health for every 1 stamina. However, I want to test out some kind of neat stuff. I want to make a class of like robots that doesn't use stamina and just has like basically they're immune to everything and they just have like energy that they wear down. I want to use that mechanic for a run away from the boss and hide and let him use up all his energy mechanic for one of the bosses here. So what we're going to do is we are not going to define primary stats at all for the game manager right now. And we'll go into the channeler class. The channeler class, we will duplicate that array element here, and our channeler will first get stamina. They will get a budget per level of 10. Stamina will not affect any secondary stats for the channeler, but it will give him a resource of health at a resource per point of 10. He'll get intellect, which will, let's see, 5 per level. No. He will get intellect at 10 per level. Intellect will be converted to spell damage at 1 point per and at a critical strike rating. Intellect will provide our channeler with mana at 10 mana per intellect. We don't really need to give this guy agility, but I'm going to do it anyway. Because, like, I mean, he should get some agility, even if it's not very much. He's not going to get any power from agility. He won't even benefit from critical strike from agility, basically. No resources from it either. We'll duplicate that, and we'll give him also strength. You know what, let's put strength above agility here. And similarly, he will basically get no benefit from it, but I just wanted to show up for him anyway. For the fighter, we will give him stamina, 10 per level. Stamina will not provide any benefit to his secondary stats, but it will give him health at 10 per point. He will also get agility. We will also give him intellect, though it's not going to do much and he only gets 5 per level and it doesn't benefit him with any secondary stats or resource conversions. Also, he'll get strength at 5 per level, but he will really receive like no power benefit from it. Ranger character class here. We will need to double that. We will give him stamina at 10 per level. He will get no secondary benefit from it. He will get health from it at 10 per point. He gets some agility. He's also going to get some intellect here at 5 per level, but he won't receive any resource or secondary stat benefit from it. And finally, duplicate that and give him strength at 5 per level with no real benefit from it. Our warrior character class here, we're going to duplicate strength here. His primary is going to be stamina, budget of 10 per level, no extra benefit from it for now, but he does need to get health at 10 per point. He gets strength, he gets agility, and we will give him some intellect at 5 per level, but he's not going to get like any benefit from it at all. Okay, perfect. So now we have all those classes defined. All right. Now I want to make the LunaMech character class, to be totally honest, because this is going to be kind of a neat class. So the LunaMechs are immune to all types of damage and operate on solar power stored in an orb in the center of their body. And I'll use a regional description for the character class. Actually, you know what I won't for now? It doesn't need an icon, so we don't need any ability names. We don't need any trait names. We don't need any armor class. We don't even need any weapon skills. The LunaMech is going to get a stat here, and the stat is going to be called solar energy. This will be its equivalent to stamina, so it will get budget per level of 10. It will not receive any secondary stats from it, and actually, just a second, it's not solar energy. The resource itself, the resource name is going to be solar energy. Okay, so the resource name itself is solar energy, but the stat is going to be called solar orb size, for lack of a better word. So that means we need to go create a stat called solar orb size, and then a resource called solar energy. So for the stats, let's see, we created wisdom as a stat. We need solar orb size as the stat. And then we've got character stats. And then we will need solar energy as a power resource. Solar energy, just duplicate energy here. Call this one solar energy power resource. Basically, there's no regen per tick. No combat regen per tick. No limits on the maximum amount. Change the name here to solar energy. And used by LunaMex. Okay. So now our LunaMech character class uses solar orb size as his stat to allow him to store solar energy, which is basically his primary stat instead of health. And I suppose that means, let's see. I'm just looking at power resources right here, right? Because if we look at the warrior, oh, right, because warrior doesn't get rage conversion. Let's just look at the channeler here for a second. Channeler gets a power resource of mana. Yeah, I think I want to keep... I'm sort of torn. Part of me wants to keep power resource as its own thing. Because otherwise, in order to figure out if a character had a power resource, you would have to basically loop through every single character stat it had, and then every single primary to resource conversion for each of those character stats. And if you had like a power resource where you didn't get any direct conversion from it, like rage, for example, then that would be no good. So we'll leave that basically as a separate thing. So basically what that means is LunaMechs need solar energy. Okay, next thing we need to do is we have mana as a power resource. We actually haven't added health as a power resource yet, so we need to do that. Health power resource, and it's called health and used by almost everything. And then, you know what, I'm just going to leave the regen per tick here. Let's remove the combat regen and keep the out of combat regen at like 2% of your health for now. And the next thing we need is a color green. So I think we can find a color green from our unit frame. If we go into the scene view here, we're using that color green. So what we want to do is look for our health power resource, click on the eyedropper and select that color green. And yeah, I think that'll be fine. Okay, so let's save that. And is there anything else that we actually need to do here? We made a LunaMech character class, so we have this unit here called the hostile LunaMech, and our hostile LunaMech unit should no longer be a warrior. He should be a LunaMech character class. And we need to adjust his combat strategy. So the LunaMech, let's see, a hostile LunaMech, this is his unit profile. There, LunaMech combat strategy. So on his combat strategy, we're going to allow him to do laser explosion all the way down, basically. We'll change the music at like 50%, but the ability is going to be laser explosion. So we're just going to dodge him the entire fight, basically, until he kills himself with his laser explosion. So what we want to do is we want to look for the LunaMech laser explosion attack here. And we want the ability as opposed to the effect. And we need to give this thing a cost. And the power resource name, let's see, we want him to be able to cast, I don't know how many of these, 10 maybe. So power resource cost per level is 10, and the power resource name is solar energy. And now our LunaMech should basically kill himself as he attacks us. So the next thing we need to do is we need to make a way for the character to actually die when our resource of any type reaches 0. To do that, let's go look at solar energy. Whoops, wrong one. We need to look at the solar energy power resource. And I think what I want to do is we will add like a tick box here, like resources health, and that way you could actually make multiple resources health. You could have like like, I don't know, 2 gas tanks, and one's like a primary and a backup, and when they're both empty, like, you're done. So why limit ourselves? So let's go ahead and do that. So we'll go into the power resource class. We'll add a new heading about health, I suppose. We will make a tooltip, and the tooltip will be, let's see, let's add the serialized field first here. So this is a private bool, and we'll just call it, I don't know, is health. Make it false by default. If true, let's see, okay. When all of a character's health resources have reached 0, they are considered to have died. Multiple health resources are allowed. Okay, awesome. So we could have like this like really neat mechanic now, where you have like a boss with like a shield or something like that, and they like recharge. Like you take out their shield while they're recharging their health, and then you take out their health while they're recharging their shield, and or like instead of a shield, like I don't know, soul energy or something like undead soul energy. So even when their health is gone, they've still got something driving them. Could be a really neat mechanic. So we'll do quick actions and refactoring here. We'll encapsulate this thing and we'll save that. So now let's go back in here, and I need to check health as a health resource, and then solar energy as a health resource as well. So solar energy is health, and health power resource is health. We'll save that, and let's see, we don't have any errors now. Right, so there's still a few spots where I don't think I have removed the word intellect or health entirely. So now what we have to do basically is like all the hard-coded old code that used to hook into that, the hard-coded health, they all need to be removed and replaced with references to the new power resources, checking if that power resource actually qualifies as health. So I don't need stamina, intellect, strength, or agility. I don't need current stamina, intellect, strength, or agility. I do not need current health. That means we can remove all of these properties. And finally, we can remove max health. Yes. Okay, good. So we'll save that. And now we have a few issues. Okay, so this is where we actually have to hook into the attack system. Reduce health is actually called, I think, by character combat. Same thing with like set health and recover health. So we need to change that. It can't be health, it has to be like resource. And we'll need to do something about this whole try to spawn dead thing as well. Okay. Also, I'm thinking at the power resource level, I need to add another Boolean, and that Boolean should let us know basically like should we refill on resurrect, and yeah, we should know whether we should refill this on resurrect or not. We don't want to refill mana, but we do want to at least recover some health. I haven't decided specifically on like Yeah, on a good mechanic for that though. Okay, so let's just deal with what we've got here, reduce health. So we're gonna find all references to reduce health, and here we have take damage common. Okay. Take damage common allows us to do mana drains, or I mean the take damage functionality allows us to do mana drains. So let's just see, process take damage. Now we're calling reduce health here. This is not what I'm looking for. So we need the attack effect ability, because I want to go see, we already have a mechanic for basically reducing mana, and we're just going to use that same mechanic because it's a generic mechanic. So we need to go to the attack effect, and here we're doing use health amount. I think I need to go down to the amount effect. There, use mana amount. Okay, so essentially I was only applying that. I think I'm actually only applying use mana amount to heal effects potentially. Yeah, so we can pretty much, I think, move basically all of the attack effect logic down into here. So let's see, what we actually want is to look at the heal effect code. So if we go to amount effect and go to implementation, we'll find heal effect, and this is where you can heal people's mana because I have a mana refill. Okay, perfect. So let's remove this commented out code right here because it's not needed. And here we go. We have recover primary resource. This is basically what we're hooking into when we do some sort of action. So let's go look at an attack effect in the inspector. So we've got a sword attack effect right here, and we have this amounts section, and the amounts section is basically you can do a health amount and you can do a mana amount. So what we want to do is configure this, because health and mana are no longer a thing, like at least as far as the engine is concerned. We want this to be generic, so we are gonna need another one of those lists of nodes basically, and for each one of the nodes in there we will be able to put in a resource type and then the min, base, amount per level, and max. And I'm just thinking whether or not I should put damage type inside that node or not. I will worry about that in a sec. So I guess we should make a resource amount node. I don't think we have anything called a resource amount node yet, and that needs to go into amount effect. So let's go into the amount effect code. Let's just close like a whole pile of this stuff here so that we can see what we're working with. We'll go to the amount effect code, and we need a resource amount node. So we need a new system.serializable, and it's a public class resource amount node, and it's going to have a new serialized field, and the field is going to be called resource name. This is a private string. And let's see, we'll add a tooltip here. And the tooltip is basically going to be, this is the resource to add to or remove from. Then we need all of these things, basically min, base, etc. So we'll actually move those off the amount effect class, and we will move them down to the resource amount node. So we'll have min amount and tooltip that basically says the minimum amount, yeah. We have base amount. The base amount is, actually, okay, let's put the minimum amount, if the minimum amount, the value will be raised to if it is lower. I don't know. Okay. For the base amount, this is going to be the amount not scaled by level. This will be added to any scaled value. And then another tooltip here, and this is amount per level. This amount will be multiplied by the character caster level, not the target's level. And finally, max amount, we'll bring that down here. And tooltip, if the amount is higher than this value, it will be lowered to this value. 0 is unlimited. And I actually like that way of describing it a little better. I think it's clearer than what I put up here. So we're going to put, if the amount is lower than this value, it will be raised to this value. Okay, that looks good. So now we have resource amount nodes. So now we need a list of resource amount nodes. So new serialized field, and I will do it private for now, and then we'll make it protected afterwards. So private list of resource amount node. Resource amounts equals new list of resource amount node. And then we'll put a tooltip over top of it, just because I like tooltips. The resources to affect and the amounts of the effects. Okay. We'll save that, and then now we're not actually going to be able to look at this in the inspector yet until we go and fix all these error messages. So we'll need to go fix all those error messages so that we can actually see that show up right here. Also, we need to change a bunch of code in here. So if we look at amount effect, we have calculate ability amount and perform ability hit. If you look at heal effect, we are overriding perform ability hit and using the calculate ability amount. Okay, so we'll keep heal effect. We'll keep attack effect. I like that whole separation, but perform ability hit. Like, I think what we can do basically is we can actually move all of this logic down into the amount effect class, and then we'll basically pass these values up to heal effect and attack effect. In order to get them to actually either call a recover or call a reduction. So let's go ahead and do that then. If we look in amount effect, basically the override that we have in heal and attack effect will have called this after it did its thing. So its thing will be done right here. Now we can basically remove, let me just make sure actually that this code is like completely identical, because what I'm going to do is basically just delete this top block right here, because this bottom one already deals with resources instead of health. So also what I want to do is I should actually compare this to the damage code, and actually maybe I should see just how different it is here. Yeah, you know what? Maybe it looks like we have some different stuff happening here. So basically, we don't have to actually care, like with a heal, we don't care whether the ability hit. We don't even use like hit or miss chance, pretty much. Interestingly enough, I'm actually kind of thinking maybe we should. What if we're like muted? What if we're muted? No, I don't know. What if we have a high chance to miss? I'm not sure. Let me think about it. Okay, so first we set the amount to 0, we set the magnitude to normal, and if we use it, then we base the total amount on the base amount plus the amount per level times the source level. We make an ability key pair calculating the ability amount, sending in these 4 parameters, and in the heal effect we calculate the ability amount, sending in those 4 parameters. We get the final amount, we get the combat magnitude, we plus equals the input dot health amount times input multiplier. Doing the exact same thing here. Okay, you know what? This is totally fine. Yeah, here's a really cool one. What if our character's drunk and we have to perform like a drunk check? He can't cast spells when he's drunk. Okay, so this code is totally fine, I think. Source equals null or target equals null return. We don't actually do that here, but we kind of should, I think. So next, what's different about this? Well, if we look at the health amount, actually maybe not anything. We take a new ability effect output, we add the health amount to it. If it's greater than 0, we do that. Okay. Prefab locations. Also done right here. We do it at the end of that second loop. And finally, source.process weapon hit effects. This is the only thing right here that's different. Okay. For this, we can do something. We can just call like a perform extra processing command. That's all that we'll need to do. Okay, so essentially, all this code right here, every single last bit of it can be moved right down into a mount effect. And then okay, so now what we want to do is, since we've moved all that code down here, basically we're not doing any of that anymore. We'll be passing the ability effect input straight down. And then we will process weapon hit effects. I think that will work. And then essentially what we want to do is we will call into a new method. Basically, I think we've already got perform ability hit. We're already using that. We're already using calculate ability amount. I need a new method called process ability hit. So this is going to be a public virtual void process ability hit, and we are going to send in these. Wow, this is supposed to say reflect damage, not refect damage. Okay, so what we want to do is we want to copy this right here, and we want to put it inside of the override for process ability hit. And this will need to accept, whoops, these parameters. And so we'll need an ability effect input, which is actually ability effect output. With an E. We will need this, which is an amount effect. Looking at this, we pass in ability effect. We will need the combat magnitude, which is of a type combat magnitude. And we will need an I ability caster and an int. Okay, good. So now that we got that, we can basically take this code right here. We can go into attack effect. We can create a public override just a second. Did I call that process ability hit? Yes, I called it process ability hit. Good. We will call the base And we need to send in the target too. And then this is just final amount. So processability hit needs a game object target. So we need to go down to the base, and we need to accept a game object target, and then in the take damage code we need to send in target. Right, we're not sending that in to take damage, we're sending that in to process ability hit. Okay. And here we're going to send in just the entire ability effect input. So next what we need to do is I'm going to rename health final amount to just final amount. And then everything else looks okay. All right, so then we can save this, and what we need to do is we need to add this processability hit method into heal effect. And here we actually do this recover primary resource instead of a take damage. We send in final amount here, and we just ignore the ability effect input because we don't care if it's reflect damage. Okay, that looks good. So then basically we don't need to do, whoops, wrong way, this way, any of this stuff right here. And we're just going to send in ability effect input here because we haven't performed any processing on it. In fact, honestly, we don't even really need this function now. I'm just going to leave it here anyway because who knows, I might find some reason for it to exist later. Okay, so now let's go back in and see what kind of errors we have in the compiler here. Lots of errors. So what we need to do is go fix all that stuff because I want to get this stuff to show up in the inspector here. So let's see what kind of errors we get. Oh, max health, yes. Okay. We still kind of need, let's see, when our resource that is considered health is full, we still need a way to check this like disabled health bar. Let's see where else we'll be using that. Okay, this one's easy to fix. Let's actually fix this right now. So here, these are all hard coded. We need them to not be, so we're going to run a for each loop here. And we're grabbing player manager.myInstance.myCharacter.myCharacterStats. dot primary stats. And this is a dictionary of string keys. So we need to either basically grab the string or the keys. Or grab like a collection, like a key value pair out of it. So I think we're going to grab the string. We'll grab the keys. So basically for each string, and in this case the string is stat name in here, then we're going to do this stuff right here. And the update string will be the stat name. And then, not state name, stat name. And then we will be grabbing the value. So we're grabbing character stats dot primary stats based on the stat name dot current value. And then we basically need to check if the current value is not equal to the base value. Then we're going to display some information to let us know that the some information to basically let us know that our stats have been like adjusted upward or buffed somehow. So let's see, we would need to get the base value here, which is base stamina. And then we need the base value again out here as part of that calculation. And then we need the current value right here. Okay, and I'm thinking, you know what might be good, just to maybe put all that stuff here just so we can kind of see it a little bit better. Yeah, okay, good. And then now we don't have hard-coded values anymore. We don't have to refer to stamina, strength, intellect, or agility. And this is on, yeah, the character panel. Okay. So bye those things. And now we need to deal with health because the character doesn't have a current health. This is kind of an interesting one. Basically, I think what we are going to do is loop through the stats and just find the first one that's a health stat, and we're just going to show that one and just consider that your primary health stat. There isn't much else we can do about that. Let's just let this compile here because I just want to see. We cleaned up a few things here. Let's see, we've got the health here over in the character panel. What other kind of issues do we have? Health potions, yes. So health potions basically can't be a thing anymore. That's okay because we actually have a new class, I think, called like Power Resource Potion. Let's go to castable item and go to the implementation of it. Because honestly, we can pretty much, I think, just delete health potions. Yeah, we have Power Resource Potion. And we already calculate power resources based on it. And so this should say your power resource.name is already full, actually. Okay, so honestly, yeah, we can just delete health potion. No longer needs to exist. So we'll get rid of health potion. And this probably fail to work now, the health potion item. So what we're going to do is we're just going to assign the health potion item as a power resource potion instead. And for some reason in Unity you always have to do this twice. There. And I think I basically like lost all the serialized properties. I will go through and fix that later though, so that's not a big deal really. Health potion. You know what? Power resource name, health. Okay, so yeah, let's see what other errors we have now. So now we have this whole concept of character stats that's got a whole pile of stuff to do with health. And that, I think, is pretty much it. The save manager, we need to fix this code here. Basically, we need to store a list of primary resources. And in fact, actually, you know what? I think we do, because right here we save resource power data, which technically will save our health. So I'm going to put moved to resource power data. And then let's see what the error is actually in resource profiles. Nothing, I don't think. Okay. So for current health, let's find all references to that and just see who's calling it. We call on health changed. In the nameplate controller, as soon as we set, and let's just go to the definition of that, because this is actually a really bad name for this function. This is not onHealthChanged. I want to rename this to processHealthChanged, because onHealthChanged gives the impression that this is something to do with like delegates, and it's not. So we're going to call processHealthChanged. Let's go to the definition of that. And processHealthChanged is basically going to cause a health percentage update, which will update the health slider in the nameplate controller. Do we have like on resource changed on primary? We don't. We don't mention resources at all, which is kind of interesting. Oh, you know what? Mana. That's why. Because we call it mana. Okay. Looking for the word mana. That's not what we wanted to find. The system event manager. Wow, do we not actually have the word mana in here? We may not. Oh, no wonder, because this is a nameplate controller. I don't even know what I'm thinking. I'm thinking this is a unit frame, and it's not. This is a nameplate. This is the thing that goes over top of the character's head, which is something completely different. So I think we can actually deal with this basically by just treating the character's primary health resource, or even just like the first resource in their list, as their health resource. So what we'll do then is we have character stats. We will grab primary stats 0 dot current value, I think. What's going on there? Right, this is a dictionary. So you know what we're going to do actually? We'll actually go into character stats and we'll have current health and max health defined for backwards compatibility as the amount of your primary resource. I actually kind of like that. So current health, max health, go into character stats, go to the definition, we'll make those into properties. So we have a no, we want to go into character stats. Where is that? Here. So just for backwards compatibility, do we have current health anywhere? I don't think we do. These are all you know what? Look at this. We already have my max primary resource and my current primary resource, which is power resource list 0. That's actually exactly what we're going to use. However, why don't I just even make it even simpler? So basically public int current health, get return current primary resource. Public int max health, get return max primary resource. And then we'll just hook up a bunch of pointers into those things to fix all of the sort of broken links, hopefully. So this one looks fine. Can I clear this? It's still complaining about something. Right, of course, that's because I didn't save it. So we're just Control-Shift-S is going to save all our files, and then it can recompile. Okay, there. So basically, current health, max health. Current health, max health, so here we're just going to Control-Shift-F, find and replace in the current document current health with a C, matching the case, and replace all. Similarly, oh yeah, actually that's kind of an issue. We can't actually directly reduce that. That's for display purposes only. However, we can replace my max health with max health in the current document matching case. And I just want to see, is this the only place where we're actually referring to those? Good. So now we have just a few combat strategy. Okay. Okay, that's great. We can just basically call current health and call max health. And similarly, current health and max health. We'll let those errors go away. And finally, we're back to character stats. Okay. Reduce health and set health. And let's see, we have a few more errors down here. Current health equals 0. Okay, so set health we actually want to set our max primary, or set our primary resource. So to set our primary resource, set health actually plus equals. So let's see. we can set primary resource amount. We can recover primary resource. Okay. Set primary resource amount. So first thing that we want to do is set it to health. I want to go check and just see if that's, go to the definition. This is a new amount. So this is correct. We're doing it the exact same way. I don't know why I called this set, because we're adding. So that's fine. And then we want to set the primary resource amount to this mathf.clamp value. So set primary resource amount. You know what? I think actually we already do the clamp in there, don't we? Let's go to the definition. We clamp it. We already clamp it. We don't need to clamp it. So basically just all that right there. Gone. Okay, much better. And we can do the same thing here. We can basically go set primary resource amount health. And this is going to be like this value times -1. And so then we're basically just going to set it, which will allow us to clamp. And then we can die like we normally would. Perfect. So this is going to be amount here. Okay. We get rid of all our errors now. Maybe one more error. Okay, so here what we want to do, our set primary resource amount call doesn't actually set it. It actually adds to it. So I think we want to change that, because I'd actually like a call that actually sets it just directly to whatever value. So let's look at that. We have set primary resource amount. And I just want to see if we have any other code in here. You know what? There. Set resource amount right there. So set resource amount just sets it directly. Okay, so what this means is that when I'm setting it to 0, I can set resource, just keep on pressing back here. Perfect. So basically set resource amount, and in this case the resource amount is going to be primary resource dot my name to value of 0. And then we can fire that method. Okay, great. Now hopefully we'll be able to compile, and then we can go look at those attack effects. And set all their values. So we'll look for some attack effects here. Okay, so here we go. We need one resource amount. The resource name is health, and the base amount is 10. Okay, that looks good. So this is how we're going to handle stuff now. So basically, any attack can drain any resource. Your attack can drain health, it can drain mana. Your attack could technically drain energy. Why not, right? You know, and your attack could drain solar energy, whatever resource they've got. Perfect. So basically, we need to pretty much do this with like all the attack effects that were previously using health. Wow, this sword attack effect is terrible. 1 health base amount and 0 amount per level. Okay, so right, we got resource amounts. Resource amount is health, base amount is 1 and 0 per level. Okay, that's good. I'm not going to bore you all with me going through and fixing all the attack effects. I think I'll do that a little bit later. And what else do we need to do now? So basically, any attack can do any number of resources, right? So what we want to do is in amount effect, we're performing an ability hit. And where are we getting this final amount from? We're getting it from calculate ability amount. You know what? Look at this. We're still referring to these old health amounts here. That's what the problem is. Okay. So what we need to do is, this is amount effect. Here I feel like this needs to be a for loop. This needs to be a for each loop. And essentially we need to loop all of this. The prefab location only needs to get set once, but every final amount needs to be calculated. So to do that, we will loop through our, and we don't have health amounts anymore. We have a list of resource amounts. So we want to go through each resource amount node in our resource amounts. So for each resource amount node, and I spelled that wrong. Call it resource amount node in resource amounts. Then you want to do all that. Now okay, so what we need to do here, we need to make a new ability effect output, but we need to make it outside of the loop. And ability effect output can't have health amount. It needs to have a list of basically the exact same type of nodes that we're using, because we're passing these on to subsequent abilities. So let's go to the definition of that. We'll look at this object here, and you can see, actually, you know what? I want to grab one of these lists here first. It's a resource amount node. So here we have health amount and mana amount. We're not going to serialize this. We're just going to make this a public. We're going to remove health amount and mana amount. Then okay, so what we want to do here is we want to grab the ability effect input amount object that is the same as the type of resource on the resource amount node that we are attempting to use. So to do that, let's see, what we want to do is we'll create an input amount. So int input amount equals 0 for starters. And we need to run a for each, and we'll be looping through the ability effect input dot resource amounts, which will give us a resource amount node. So we're looking through all the resource amount nodes, and we want to call this actually the underscore resource amount node, because we're already inside a block that is using the resource amount node name. And then if underscore resource amount node dot why am I not getting back any properties on that? Equals and type, that's not right. That's because I'm not exposing this anywhere. Okay, so, right, we need to expose all this stuff. Resource name, min amount, base amount, amount per level, and max amount. Okay, so if the resource name of this node is equal to, and in this case we're already in the regular resource amount node. So we're in the regular resource amount node dot resource name. Okay, good. If that's the case, then we are allowed to add to this amount the actual amount. So underscore resource amount node dot just a second, go to the definition. Oh, we need to make these all public. And actually, it's kind of a hack that I'm using a resource amount node here. Maybe I shouldn't be using a resource amount node. Let's actually make a new class for that. Let's make a resource input amount node. Doesn't need to be system.serializable, and just has a public string resource name and a public float amount. So then we will call the resource input amount node instead of the resource node from ability effect output. So resource amount input node. Okay, much better. So going back, we actually want now resource amount input node. And we want lowercase resource name. And we're grabbing from it the amount. So this is the final amount will be plus equal to the resource amount node dot amount, which is this right here, times our input multiplier. And finally, we don't need to care about health amount. This is actually, oh wait, you know what? Okay, hold on. I think I did that wrong. Final amount plus equals input amount. Actually, that's yeah. Let's try this again. So we want to float input amount equals 0f. Input amount will plus equal directly the input amounts. We're going to add all of the input amounts up, and then at the very end of it, we will take the input amounts we'll multiply it by the input multiplier to get our final amount. Then we want to take the resource amount node dot resource name and set the input node in the ability effect output with that value. Okay, so basically, I think ability effect output should have a function to let us do that. That seems like the kind of thing that we should actually like encapsulate inside of here. So this is a class, which means we can give it a method to do that. And what we want to do is public void add resource amount, and we will add a string, and that's going to be the resource name, and then a float for the resource value. And we need to set a bool now, found resource, and set it to false. And so for each resource input amount node, resource input amount node in resource amounts, if, let's see, the resource input amount node dot resource name is equal to the resource name that we're asking for, then the resource input amount node dot amount plus equals the resource value, and then we found our resource. If we didn't find our resource, then we will add to the resource amounts a new resource input amount node, passing in the resource name and the resource value. So we now need to go there and we need to make a constructor for this, making it a public resource input amount node, accepting a string resource name and a float resource amount, setting this dot resource name equals resource name, and this dot resource, this dot amount equals resource amount. And actually we don't need the this because the names don't conflict. Perfect. So now we can pass in one of these new objects and we can just add otherwise. Good. So that's good. So now we can add a resource amount to the node directly. So now what we want to do is ability effect input dot add resource amount, adding the resource name, which is our resource amount node dot resource name, and sending in the final amount. Okay, And if the final amount is greater than 0, then we do all this, and then we're going to do it all over for every single resource in the amount effect. I think that's good. Let's just let it compile, and wow, will you look at that? We got a pile of issues now. Okay. So we have this function called apply input multipliers. And so I guess what we can do here, okay. We pretty much need to copy all of the ability effect input amounts from the old object, applying the multipliers to them and saving them back to themselves. Okay, now that's kind of interesting because okay, I'm not going to modify the collection, so I think we're okay. We're okay to loop through this and update it on the go because I'm not modifying like values or anything. Okay, so what we do basically is for each, and we're looping through ability effect input dot resource amounts, which gives us a resource input amount node, resource input amount node, and basically we want to set the resource input amount node dot amount equals int resource input amount dot amount times input multiplier. And if you're scratching your head wondering what the heck this resource input amount code is all about, essentially what this gives you the ability to do is like damage reflection. So when someone does damage to me, I actually track that, and then I send in the damage that was done to the next ability, which can actually take this as an input. So for example, what I can do is I can trigger off of a hit and let it know that it should basically take this input value, the damage that my character took, like say 100 damage, multiply it by an input multiplier, like say 0.1, to come up with a number of 10, and then I can send that in like as an input to my next ability that attacks the outgoing character. So it's really good for like life drains and stuff, which is exactly what it's meant for. So here we just want to do that. Okay, good. That gets rid of that code. Let's see where else we're using this kind of stuff here. So here we want to do exactly the same thing, and I think in fact I'm just going to copy this for loop because I think the issues that we're getting right now are going to be very similar. So what we want to do is loop through all of the nodes in ability. Oh, this is an interesting one. Okay. We need to loop through all the nodes in ability effect input, and then we need to set them in a modified output. So in this case, what we're going to do is we're going to call modified output dot add resource amount, adding in the resource input amount node dot resource name, and the value is going to be, let's see what we want to do here. We need to get the resource input amount node dot amount, and then multiply it by the output share. And if you're scratching your head wondering exactly what this is doing right here, essentially when we perform an AOE, we have the option to split all of the input equally between whoever is receiving the effect. So basically what this means is that I can do damage to an enemy character for 100, say for example 100 damage, and then I can actually like perform a heal on my group if I'm making like a discipline priest or something, where I split that 100 damage actually as a 100 health heal to all my party members, and if there's 5 party members, they would get like 20 of that 100 each. So that's what we're doing right here, is we're basically doing like input splitting on that sort of stuff. The ability system is pretty flexible. It's one of the things that I'm really happy about in the engine. Okay, here it looks like basically we're just doing a direct copy this time. So we can pretty much use this code right here. And what we'll do is valid target node dot ability effect input dot add resource amount, just directly based on our current ability effect input, which is already there, which is our resource input amount node with no output share multiplication. And then we can get rid of that code right there. Okay. Let's see what else we got to deal with here. One more issue. Okay, process take damage. So in character combat, this is where we actually set that whole initial thing. And character combat process take damage needs to take the damage to the correct place, because essentially this process take damage method could be a mana burn. So I think let me just right click and find all references to this. So we call this take damage common method. Let's find all references to that, which is only performed in, or basically called from this take damage method. And if we find all references to this, it's called from a couple of places. We're overriding it in player combat and AI combat. Essentially in AI combat, you can be in evade state, So we can override the damage and basically say AI never takes damage in evade state. In the player combat, we're overriding it and basically just forcing the player into combat as soon as he takes damage. I don't honestly know. This feels like it's not needed because I think we already do this like in the character combat. In fact, let me just go to the definition of that. I'm pretty sure like take damage common or something like that. Maybe process take damage. Well, what do you know? Do I even enter combat here? I set last combat time. Ah, there we go, enter combat. Okay, so essentially that player override pretty much isn't needed because we're already like entering combat there early. Okay, so this is the only one that we really care about then. This is when we process this ability hit as part of the attack effect and amount effect. And this is the last place where we could have potentially sent in information about what type of damage we're doing. So if we find all references to process ability hit here, we're calling it right here. Okay. So in amount effect, we've got a resource amount node and we've got a resource name. But we do not pass it through to process ability hit. So we need to do that. So we will pass through our resource amount node dot resource name. And that means, okay, we need basically a string resource name. So let's go to the definition of this. We will accept a string resource name. Then we will go to these overrides and we will accept string resource name and pass through the resource name. Then we want to go to this other override here and accept the string resource name pass through to the base the resource name. Alright, and finally what we'll need to do is pass in the resource name to the take damage method. Now, for the heal effect, we actually need to recover resource, not recover primary resource. So let's just see, do we have a recover resource method? Looks like I don't think we do. let's go to the definition of recover primary resource. And we'll make a recover resource, I guess. So public void. We'll actually just copy this exact thing here. And this will just be recover resource. And I guess we want to send in, we'll send in the resource name here first. So resource name and int amount. We will set resource amount, sending in the resource name and the amount. When we look at set resource amount, no, this was one where we actually literally just set it. What we want to do is add resource amount. So we will add resource amount. Then for the combat text type, I'm going to fix this later. We've got gain mana here. It's fine for now. I don't really care. It's not going to affect anything negatively. Okay, so let's go back. And finally, we can, oh, just a second. Recover resource, what was I doing here? Right, Control Y. We can recover resource, sending in, and this is where we actually need the resource name, right? Yeah, string resource name. So recover resource accepts the resource name as the very first thing here, so resource name. Good, and then we don't need to worry about recover primary resource. We will recover the correct resource. Excellent. And finally, now we need to do that for attack effect. And here we have take damage. So take damage needs to also accept resource name. So let's go to the definition of take damage and find all references. We've got 2 overrides, and the only place we call it is from attack effect. Excellent. This makes it super easy. Take damage will have string resource name as its first parameter. We're going to copy that. We're going to go add it to the overrides. And then just send it down when we call the base. And that looks pretty good. Okay, now when we call take damage, we can send in the resource name. Excellent. So now we can go to the take damage method and we can actually properly remove the correct resource. This is correct. If the damage type is physical, we are going to be removing from armor. If the ability effect melee range, this is great. Okay, take damage common. Take damage common. Let's find all references. We call it only from this spot, so we will then once again pass down the string resource name. We'll go to take damage common and add a string resource name as the first parameter. We have two things to modify here, process take damage and reduce health. So process take damage, we're going to go to the definition of that. We are going to find all references. It's only called in one place. Good. So we can send in the string resource name. All right. And finally, we can ask the ability effect input dot add resource amount adding in the resource name that we just received and passing in the damage value. Okay, now we need to go to this and we need to actually create a new function here just called set resource amount, because basically we need to do the exact same thing, but instead of plus equals it's just equals, because we were just doing a direct assignment when we did this here. So we're going to call set resource amount. Okay, and then we can go back and we have, I think, let's see, take damage common, process take damage, send in the resource name and the damage amount. Finally, we don't want to reduce health. We want to reduce a resource. So base character dot character stats dot reduce, and I don't think we expose a reduce resource. Let's see, we have reset resource amounts, recover resource, recover primary resource, use power resource, which isn't exactly the same thing. Get resource amounts, current resource, add resource amount. We actually don't have reduce resource. So let me just go down to use power resource here. Do you know what? We can actually just call this directly. There's nothing in here specifically about using it. This is actually just a direct reduction of a resource. But we should actually throw a wrapper around it, because essentially we want to check if this resource is a health resource, and if it is, we want to trigger a death check if that resource amount has hit 0. So let's do that. we will make a public virtual void reduce power resource. And we will just call use power resource, passing in the power resource and the used resource amount. Now we want to perform a death check. So if the power resource dot we have health is health. So if the power resource is a health resource, then we want to perform death check. So we'll make a public void perform death check. And now I want to go back and I want to see this reduce health. Basically, so we'll do reduce power resource, passing in the resource name and the damage. So just looking at the way this code is working here, I might actually want to pass in the power resource directly. So we have the resource name. Let's go back to take damage common. I believe it's actually amount effect, which is where we have this here. We don't need the resource name at any point. We just need the resource. So to avoid a runtime lookup of that resource, what we should do, you know what I'm going to do, let's just look for amount effect here. Get rid of rain effect, AoE effect, ability effect output. Here's amount effect. Amount effect is a scriptable object where we can get a reference to all the resources in our resource amount nodes. So private power resource, power resource, and then quick actions and refactoring encapsulate the power resource. Then we need a setup scriptable objects. So public void setup scriptable objects. And then we need to get a reference to the power resource. So we already do something like that. Let's see where else we're getting references to those power resources. I do it inside of the stat scaling node. So let's go back and look at our stat scaling node. Actually, okay, so stat scaling nodes are on character stats, yes. Which is primary stats. Perfect. Okay, here, good. Stat scaling node. So in stat scaling node, we do set up scriptable objects, at which point we go into this one, go to definition, and finally there we go. There we get our power resource. So we're going to copy this code out here. We are going to put it in a mount effect. We're going to put it in the resource amount node so that the resource amount node can get a reference to its power resource. Then amount effect itself is part of ability effect. So what that means is that we can override setup scriptable objects. So let's do that. We will do public override setup scriptable objects. And yeah, we'll call the base, and then we need to do a for each loop, and we need to loop through all of our resource amount nodes in the resource amounts. So for each resource amount node, resource amount node in resource amounts, resource amount node dot setup scriptable objects, and that will finally get us our reference to our power resource so that we can then pass it all the way down the stack as part of these effects. So then we're going to go back into here, and just a second, we'll pass in that to the input amount, but we will pass in the power resource to the perform ability hit. Okay, good. So then process ability hit is going to accept, instead of a string, the actual power resource. And then if we find all references to that, we'll find the two overrides, in which case we can also send in the power resource, passing down the power resource. Over here, same thing. Send in the power resource, and then pass it down to the base. And then over here, wow, how do we have a resource name? That's kind of neat. What is this? It's a string. Oh, this is a resource name. This is actually, wow, this is the name of the base describable resource. This is a terrible variable to use. It would have potentially been a big bug. So that's actually really good that we're changing that. So this should actually say power resource. And then in recover resource, here we need to accept power resource, and here when we add the resource, we're going to add power resource dot my name. Okay, this was for recover. So now we want to do the same thing for attack effects. We'll send in the power resource. And actually I'm thinking that processability hit, there might be another bug hidden in here somewhere. No, there isn't. We sent in resource amount node.resource name, not straight up resource name. So there's no bug there. That's good. Now we will go to take damage and we will accept a power resource. Power resource. Then we will call take damage common, sending in the power resource. We'll go up to take damage common, accept the power resource. Whoops, whatever that was. And finally, we can go to process take damage and reduce power resource. Okay, so when we process take damage, we'll send in the power resource that we got. And when we reduce the power resource, we will send in power resource dot my name. No, you know what? We actually need to send in the power resource. Okay, great. We just sent in the power resource directly. That's exactly what we need to do. Let's go to process take damage. I don't think we need power resource as a thing anywhere down there. So for now, I'm just going to send in power resource.name because this function is fine with a string. And now with reduce power resource, we can actually reduce it based off the damage. Control-Shift-S, save everything, jump back into Unity, see if we've got any errors. We have 2 errors, so let's figure out where those are. Here, it looks like we just forgot to set power resource on one of these. And base dot take damage, just passing down power resource. Looks like we have one more issue here. Oh, you know what? Same issue. Basically, we're taking damage, sending down a power resource, and sending down a power resource to the base. Let that compile. Okay, awesome. Now we're back to no errors. So now the final thing that we need to do is we need to figure out whether or not we died. So let's do that. Basically this reduce health function, let's go to the definition, and here we basically check if current health is less than or equal to 0, die. This is our perform death check function. We're going to take this, we're going to put that into perform death check. We're not going to use this logic though. What we're going to do is we are going to make a new bool called should live. we'll set it to true. No, you know what? We'll set it to false by default, basically. And so what we want to do is run a for each loop. So for each, and we're going to loop through all the character stats. So we're looking through primary, no, actually resources, power resources, and our character, basically power resource dictionary. Okay, so in our power resource dictionary dot values, just a second, what is power resource dictionary dot values? It's a power resource node. We actually don't want that. We want the power resource, so we're gonna go and loop through the keys. So basically for each power resource in power resource dictionary dot keys, okay, so sorry, we're going to loop through the power resource in the power resource dictionary.keys. Then we need to perform a check, basically. So if our power resource dictionary at the power resource, which is the node that we're going through, dot current value is greater than 0, and this is a float, so greater than 0f, then, oh yeah, and we also need to check and the power resource dot, and this is health. So basically any is health resource that exists as a power resource will prevent the character from dying. So if this is a power resource, the current value is greater than should live is true. Perfect. So then if should live is false, then die. And there's death, based off of, finally, our generic power resource. And now the rest of the code should basically just follow the correct path for actually having the character die. And as far as I can tell, that is every single change I think that we need to do mechanically to the engine to have it properly deal with the disappearance of health, the disappearance of intellect, the disappearance of mana, and the disappearance of every other hard-coded stat assumption in the game, pretty much. So this is a really long episode. I'm going to basically test all this functionality and make sure it's working in the next episode. I hope you enjoyed that. If you did, don't forget to thumbs up the video, subscribe to the AnyRPG YouTube channel, or just leave a note in the comments. Thank you so much for tuning in, and I will see you next time.